Phobia and PTSD. Despite the difficulty in saying whether rodents experience anything like we do, we must not write off the relevance of animal research. They may still be highly similar in some ways. In fact, the case of threat conditioning can be considered one of the biggest success stories of how animal research has contributed to advancements in clinical treatments. Recall that extinction is not as simple as unlearning. Say a patient has a phobia of spiders. We can conceptually think of the spider as a CS, which is paired with some threatening event such as getting poisoned, a US that would lead to an aversive reaction. So one way to get people to become less afraid would be by the way of extinction training. We can present the CS without the US. In practice, this would amount to asking patients to interact with spiders while making sure they don't get poisoned, which is easy because most spiders aren't poisonous. This procedure in the clinic is called exposure therapy. Aside from being a rather unpleasant procedure for the patient, one trouble is extinction only forms new memories specifically for the context. So the patients will never unlearn the CS-US association that spiders may be poisonous or dangerous. All they will learn is that in this room with the clinical psychologist here, spiders are not poisonous or dangerous. But once they leave the clinic, as they go on a hike, if they see a spider, it is in a new context, and contextual renewal may very well happen. That means they may experience their fear again. Michelle Krask has taken insights from research in rodents and came up with the idea that if we want to prevent contextual renewal, one way is to do the extinction training in many different contexts. Better still, we mix up these contexts and switch between them back and forth. This way the brain may learn that the extinction phenomenon is not so specific to one context only. Instead, it may generalize the fact that the CS no longer predicts the US to all new contexts. This can lead to much improved treatments. Remember earlier how I mentioned that learning new extinction memories depends on activity in the ventromedial prefrontal cortex, the VmPFC? The idea is the VmPFC, being part of the prefrontal cortex, may be able to send contextual information to the amygdala to inhibit the threat-related signal, just for the specific context in which extinction is learned. This may be why we don't overwrite old memories, because we have this sophisticated VmPFC mechanism to keep track of context. And we may add new inhibitory extinction memory to new contexts instead of overwriting existing USCS entirely. But what if one's VmPFC is damaged? Curiously, one study found that war veterans with VmPFC damages actually rarely develop PTSD compared to other soldiers with injuries to other parts of the brain. One intriguing interpretation may be this. When the VmPFC is damaged, we cannot form new extinction memory specific for the context. Therefore, when the CS is unpaired with the US, we had no other option but to overwrite the previous CS-US association. If this was true, turning this mechanism off in the VmPFC may be a useful way to enhance exposure therapy too. As far as we know, this has not been established yet. But from this kind of thinking, you may come to appreciate the power of cognitive neuroscience for understanding and improving clinic treatments.